Hello everyone, welcome to my channel. Today we are going to study two topics. First one is Introduction to Digital Electronics and second one is Basics of Binary Number System. Now first of all we have to understand clearly that what are analog signals and what are digital signals. Analog signals are the continuous signals that has certain value at every instant of time in a particular range. And digital signals, when any analog signal is converted into a signal which has two discrete values, which is represented by low or high, or we can say 0 or 1 respectively, is known as digital signal. It is represented in a diagram below. Now, analog signals can be converted into a digital signal by first sampling and then quantization. Now, the process of sampling and quantization is combinedly called analog to digital conversion, or in short ADC. Now there are various advantages of digital signals over the analog signals. They are more immune to noise. The digital signals carry more information per unit time as compared to the analog signals. That means they make much better use of bandwidth than that of the analog signals. And the quality of digital signal is also better when they are transmitted over long distances. Next is the digital signals are more secure. We can encrypt the digital signals. And the digital system interface well with computers and are easy to control with softwares. Due to high noise immunity of digital systems, it is much easier to store data and retrieve it later without degradation. So these are the few advantages of digital signals over the analog signals, or we can say why we need digital signals rather than the analog signals. Now, coming to our topic, that is digital electronics. Now, what is a digital electronics? Now, simply digital electronics is a field of engineering science that deals with electronic systems which uses a digital signal instead of an analog signal. And the most common units of digital electronics are combinational circuits and second one are the sequential circuits. We will study all these combinational as well as the sequential circuits in our upcoming lectures. Now, all the complex digital circuits, which are the backbone of today's electronic gadgets such as laptops, mobile phones, and many more, can be formed by making use of these two units of digital electronics. Now, number system. Now, here are the few number systems that are widely used in digital systems like microprocessors, logic circuits, and computers, etc. Therefore, the knowledge of these number systems are very essential for understanding and analyzing the designing a digital system. Now, these number systems are binary number system, octal number system, hexadecimal number system, and after that we will do the number conversion. Number conversion means how we can change this binary system into octal, octal into hexadecimal, or hexadecimal into octal, and octal into binary. Now, first of all, we will study in detail what are the binary number system, and in my subsequent lectures, we will go towards octal, hexadecimal, and number conversion. Now, what is a binary number system? As its name suggests, binary. Binary means which has two. Binary means two, only two levels. So, it has two levels. Now, it is easy to represent binary values electrically. we can easily represent two values electrically. This can be explained using this diagram. Now, how we can represent it electrically? Now, this is an electronic switch. This switch is in open condition and this switch is in closed condition. Now, this open condition can be represented in the digital form by 0, or we can say it is representing no signal. And this closed switch can be represented by 1, which means that there is a signal, or in electrical words we can say that current does not flow when your input is 0 and it flows when input is 1. Now it is we have studied that it is easy to represent binary values electrically. Now it can be implemented using circuits. We can easily implement these binary numbers using our digital circuits, which includes your gates and other combinational and sequential circuits. Now that create the building blocks of modern computers. That means that our computer relies on the language of 0 and 1. So our modern computers that rely on this language, that means it is a building block for modern computers. Now, going towards the binary number system. Now it is represented, its base is represented by 2, or small b or capital B. Now in binary number system, as its base is 2, that means it has only 2 symbols. One is 0 and second one is 1. Now each place is weighted by the power of 2. In any number system, we have a weightage of the particular place. All the information in digital computer is represented as bit patterns. Now, any information which we store in a computer is represented in the form of bit patterns. Now, what is this bit pattern? Here, one bit pattern is represented. Now, in this bit pattern, this complete string of bits is called a bit pattern. Complete string of 0 and 1. It is called a bit pattern. And only one number or one digit, it is called a bit. Single number. It can be this one, it can be this one, it can be any one from this string. So a single number or single digit is called a bit. Now let's consider one bit pattern 0 1 0 1 0 1 0 1. Now if anybody asks how many bits are present in this bit pattern, now number of bits will not only include zeros or only ones, it will include both zeros and ones. Total number of zeros and ones which are present in this bit pattern is the total number of bits in this bit pattern. So answer for this question is total 8 bits. Now we will again take example of this string. Now this pattern is represented as follows in the digital computer. In digital computer, what is the position of these bits in computer? So the first bit, starting from this right hand side, the first bit position is called bit 0. After that, this 0 is called at first bit position, and then second, then third, fourth, fifth, sixth and seventh. So this is the 8-bit string. So we have the bit position starting from 0 to 7. Total number of bits are 8, but bit position will start from 0, starting from the right hand side bit towards the left hand side bit. Now, very important thing, a single bit can represent 2 states. Now, what are the possible number of combination a single bit can represent? As we are studying the binary number system, so what are the possibility for a single bit? It may be 0 or it may be 1. So these are the possible number of states for one bit. Now let us suppose we have 2 bits. Now for 2 bits, what are the possible number of combination? There are 0 0, it may be 0 0, it may be 0 1, it may be 1 0, or it may be 1 1. There is no other possible combination with 2 bits, or these are also known as unique states, which can be represented by using 2 bits. Next, moving forward, if we have 3 bits, then what are the number of possible states, or we can say unique states, which we can represent using 3 bits? There are 8 unique states, or we can say what are the possible number of combinations which a 3-bit can represent. There are 8 combinations. These are that 8 combination starting from 0 0 0 to 1 1 1. There is no other combination using 3 bits except these 8 combinations. Now, from the previous study, we can conclude that with every bit you add, you double the number of states and states that you can represent. Therefore, the expression for the number of states with n bits is 2 raised to the power n. Very, very important thing, as we have studied earlier, that with 2 bits we can represent 2 raised to the power n, and with 3 bits we can represent 2 raised to the power 3 states. 2 raised to the power 3 means 8. 2 raised to the power, here it will be 2. 2 raised to the power 2 means 4. So there are 4 possible combination, and here there are 8 possible. So by increasing from 2 bit to 3 bit, that is what we have stated here, that whenever we will add 1 bit, it will double the number of states. So when we are adding 1 bit to, when we are moving from 2 to 3 bit, the number of states will directly increases from 4 to 8. So if we will, so you can do exercise for 4 bits, 5 bits and 6 bits and so on. So formula is simple, 2 raised to the power n. If you are using 4 bit, then number of states will be 2 raised to the power 4, or we can say 16. Now next is, this is again the bit positions shown for the bit string 0 1 0 1 0 1 0 1. Now here I want to tell you one very important thing, or we can say a very simple thing, that a group of 4 bits in any binary number system, group of 4 bits, like if I will write number 0 1 0 1, then this is called in short a nibble. Likewise, a single is called bit. So this complete 4-bit combination of a binary numbers is called a nibble, group of 4 bits. Similarly, 1 byte. Now I am writing the 1 byte number. So 1 2 3 4 5 6 7 8. 8 bits will form your 1 byte, or you can say the group of 8 bits is called 1 byte. Now group of 16 bit is called half word. 16 bits, double than, or you can say 2 bytes. Okay, so this is called 1 word, and group of 16 bits is called half word. Now very important thing, LSB and MSB, which we oftenly use in our digital subject, that what is LSB, least significant bit and most significant bit. We are again considering the same example, same bit string with having position bits 0, 1, 2, 3, 4, 5, 6 and 7. So the rightmost bit, which is bit 0 position, that is called least significant bit in a binary number system. And the 7th bit position, which is bit 7, here in this string it is 0, it is called MSB, or most significant bit. Now I have told you that this number system, which is a binary number system, has some weightage about the particular position. Each and every position has some weightage. So here we can see that this is our bit position. Number may be any. Let it be 0, 1, 0, 1, 0, 1, 0 and 1, as we have taken the example previously. But bit pattern may be any, but the weightage will remain same, that the number or the bit which is present at this bit 0 position has the weightage 2 raised to power 0, or that is equals to 1. And the number, we can say a bit which is present at bit position 1 will have a weightage 2 raised to the power 1, or we can say 2. Similarly, the bit which is present at bit 2 position will have a weightage 2 raised to power 4, or 2 raised to power 2, or that is 4. Now you can see that this weightage will increase in the power of 2. Like first bit has 2 raised to power 0, then 2 raised to power 1, then 2 raised to power 2, then 2 raised to the power 3, 4, 5, 6, 7 and so on. It will increase when the your number of bits in a number will increase. So your weightage will be correspondingly 1, 2, 4, 8, 16, 32, 64 and 128. So these type of numbers which has weightage at their particular weightage of their particular position are also known as weighted numbers or weighted number systems. So I think this is all about today, enough for today. So we will continue in the next lecture. So for any doubt, you can please comment on my comment box, and if any type of question or query, you can comment on the text box.